So, good morning. Today, we shall discuss about the bolted joints which are subjected to combined load of the initial tightening and the load due to external factors or external loading. Okay. So, till now we have seen these two as separate cases. In the first case, we have seen the bolted joints which are subjected to initial tightening only. So that is the load acting on the bolted joint due to initial tightening of the nut. And in the second case, we have seen the bolted joints which are subjected to external loads. So here in the second case, we have neglected the initial tightening loads and considered only external loads. In the first case, we have considered only the initial tightening loads and there is no external loads. But in this case, we will have both the initial tightening loads as well as external loads. So let me take an example. So here, this is a cylinder cover once again. So half of the section has been shown in this diagram. Okay, so in this cylinder cover, if you observe, so here the combustion takes place. So here this is the piston. So here there will be a piston. Okay, and here this is the place of combustion. So this is the combustion chamber. Okay, and this is the cylinder cover. See, this is the cylinder cover. Now this is cylinder block. The cylinder block and cylinder cover both are joined together by using this bolts. Of course, around the circumference, this is cylindrical in top view, and around the circumference you will have number of bolts. N number of bolts will be there. So here we have shown only one bolt. Okay, so just before joining you have tightened it. So you have inserted the bolt through the holes. Okay, and then nut is inserted and this nut is tightened. As the nut is tightened, there will be some load due to tightening on this bolt, due to which it may fail. So that is initial load due to tightening. So we must use maximum loading here, maximum effort to tighten this nut. Why? Because here in this place the combustion takes place. If this tightening is not perfect, then these combustion gases may escape through the gap to the outside. Is it right or not? The combustion gases may escape through the gap. So that's why these two surfaces must be perfectly joined together without any gap. Even a small gap will lead to the leakage of the fuel. So that's why we must use maximum load to tighten it. So that load is known as the load due to tightening, initial tightening, and during the process of tightening this bolt may fail, it may break sometimes. Okay, so that we have discussed in the first case, right? And also during the process of combustion, so here this bolt is already subjected to initial load. Okay, so it is under tension already due to initial load, and at the same time here the combustion is being taken place. So due to this combustion, these combustion gases will try to move the cap upwards because of its pressure. So some force is acting upward. So that means this bolt is also subjected to tensile load. So here this bolt is in tension due to two loads. The first one is due to initial tightening, it is in tension, and the second one is due to the combustion pressure. So this is the external load. Due to this also it is in tension. So as a result of these two forces, tensile stresses are developed inside this and it may fail. Is it right? Now while designing this joint, while designing the bolts for this type of joint, you must consider both the loads due to initial tightening as well as the external loads. So you have to calculate the total load. So here the total load can be calculated by this formula. Total load. So that is P. So this P is equal to sum of P1 plus P2. Here what is P1 here? It is the load due to initial tightening. Load due to initial tightening. And P2 is external load. So we know that this load due to initial tightening is equal to 2840 D, where D is the nominal diameter. I have mentioned this formula while discussing about the initial loads. Okay, and this is the external load, which is equal to P2 is equal to sigma T into A. This we know this. This is the external load. Now while calculating the diameter, you must consider both initial load as well as external load. So that's why P is equal to P1 and P2. And now tell me, which load should be greater in order to have a leak-proof joint? If you want to arrest or if you want to prevent the leakage of the gases through this gap, which should be higher, P1 or P2? See here, this is P2. And due to tightening here, we will have P1. P1 ఎక్కువ ఉండాలా, P2 ఎక్కువ ఉండాలా? P1 ఆబ్వియస్గా ఎక్కువ ఉండాలి. ఈ లోపల ఎంత ప్రెషర్ ఉంటే అంతకు మించిన లోడ్ ఇక్కడ యూజ్ చేసి దీన్ని టైట్ చేయాలి, అప్పుడే లీకేజ్ ఉండదు. సో హియర్ ద P1 మస్ట్ బి గ్రేటర్ దాన్, much more greater than P2. Then only leakage can be arrested. So by using this formula, you can calculate the diameter. By using this formula, you can calculate the load, and from this load you can calculate the diameter. Right. Now see here, okay, no issue. Now even though if you tight it perfectly, by using a spanner, there is a chance of leakage through this gap. So in order to prevent that leakage, here we are using a gasket. That means here this is the cylinder, and on which you have to insert the cap. See, for example, assume that this is the cylinder, okay, and this is the cap. Okay, in between I have inserted a soft material of like this, a soft material, so that I have placed the cap like this. Now in this case, if you tight it perfectly, there should not be any leakage. Is it right or not? Have you seen gaskets? If you go to an automobile workshop where the engine work is going on, so they dismantle the engine, okay, and during the process of assembly, they remove the old gasket and place a new gasket, and then we will place the cylinder head. You just observe. So that gasket is used to prevent leakage. Okay. And even if you observe our pressure cookers, which are used to cook at our home, it also consists of a gasket. Have you observed it? A cylindrical gasket, a soft rubber gasket. What is the purpose of that gasket? That's also used to prevent leakage of pressure, leakage of steam. Antene kada? So you try to use the cooker, pressure cooker, without gasket. Can you cook? No, because there will be leakage definitely through the gaps. Only if you use the gasket, there will not be any leakage, so that the pressure is built up inside the cooker and the cooking is done fastly. In the same way, here also, to prevent the leakage, we use this gasket. Right? So when you are using this gasket, then this formula differs slightly. Now this formula will become P is equal to P1, which is the external load, plus K into P2, plus K into P2. So as usual, P is the total load, P1 is the initial load, and P2 is the external load, and here K is the constant of gasket. It is the constant of gasket, or it is also called as stiffness constant. Stiffness constant of the gasket. So this K value depends upon the material of the gasket, and there are different values for this constant. Okay, if there is no gasket, then this K will become 0, so that the maximum, the total load is equal to the P1 only, initial load only. Here this factor will become 0, and you can neglect. Here I have already told you that this P1 is much more greater than P2. External load kanta initial load చాలా ఎక్కువ ఉంటుంది. ఎంత ఎక్కువ ఉంటుందంటే దీన్ని కొన్నిసార్లు నెగ్లెక్ట్ చేసేయచ్చు. ఆ కేసులో మాత్రం ఇటువంటి జాయింట్ మనం వాడగలం, మెటల్ టు మెటల్ కాంటాక్ట్ జాయింట్. ఒకవేళ అలా సాధ్యం కాదనుకోండి, దెన్ యూ హ్యావ్ టు గో ఫర్ దిస్ గ్యాస్కెట్. సో ఎక్స్టర్నల్ లోడ్ కంట చాలా ఎక్కువ ఇనీషియల్ లోడ్ మనం అప్లై చేయగలిగితేనే డైరెక్ట్ జాయింట్ వాడచ్చు, అదర్వైజ్ యూ హ్యావ్ టు గో ఫర్ ద gasket. So that's why in case of there is no gasket, then the K will become 0. K 0 aindante the total load must be equal to the initial load only. In that case it can be neglected. Okay, and this K value is different for different materials, like hard copper gasket, soft copper gasket. So there are different materials, and for those different materials there are different values of K value. So by using these formulas you can calculate the diameter. So we should solve the problems so that you can understand the things in a better way. Okay, and I will share this value of gasket for different materials also. Thank you.